Good evening, everybody. So let us start our lecture tonight. And today is September 21, right? 2021. And as you see that the first announcement is that I sent it in tutorial that I added a study guide. So please follow the study guide, okay, for the test. And our test will be next week, this time, right? Okay, so please bring your pencil, eraser, okay, and I'll give you paper and then a book. You can bring your entire book, any number of printed materials, okay, but no device, electronic device, okay. And so actually you need to open book. That means that that's not easy anything, okay. You need to search the book. For instance, if you read, if you study, if you study and if you read the book, then you will be able to find it. Otherwise, within an hour and 15 minutes, you will spend most of the time looking for the pages. Please follow check preparation, okay. And I posted assignment 1 grade. If you have any question, please email me. Yes. Yeah, if you have any comment or question about the assignment grade, please yeah, there is a mistake. I will fix that one. I will fix that one. But for your personal grade, if there is any question, please tell me. I will fix the grade book into another. Yes, okay. What else? Okay, so let us see our schedule today. So according to our schedule, so today we will discuss data structure. Like the basic data structure, you are familiar with data structure. Since you took data structure course, you took 1322, so you are familiar with elementary data structure. That's chapter 10. So the most basic data structure is an array. Data structure means how data are organized for your program. Alright. So if your data structure is efficient, and then as I discussed at the beginning, and your program is good, okay, with less complexity, then you're good. So half of the thing is that about data structures, and another half thing is about program structure, means algorithm. So you're familiar with static array, an array. But one problem is that with an array, this is fixed length. During program execution time, you cannot change the size. Okay. As a programmer, we can change it. If I run my own program, own application, then I know that there is a problem over here. I can come to the source code and I can fix it, right? But most of the programs or applications are written for people who do not have any knowledge about programming. We suppose that, or little knowledge about programming, and we develop programs for them, right? Even they have program experience or knowledge, no matter how much or how we do not provide our source code to them, right? We give our binary file or executable file to them so that they can use it. So in case the array with static array, if they have more data than the array length or size, there is an issue. So in order to resolve that issue, there are other data types like dynamic data type, right? The most common dynamic data type is a linked list. So linked list, in a linked list, data elements are linked together. So that the word means linked list, that means are linked. Linked list. So it says list plural, that means there are different kind of linked list. By saying linked list, in general it is singly linked list. So in a singly linked list, there are nodes, these are nodes, and node is the main element in a linked list. In a single linked list, each node knows who is next to it. Who is next to it? So, like maybe this is next to it, and this next to it, and this is next to it. So each node, actually here, each node contains two things: some data element and some data. For instance, maybe 10. This is maybe 20. This is maybe 5. Any data. This is maybe 6. And some address of the next node. Okay. So if there is no next node, then this address is denoted by null. In some programming language, null is defined as all in uppercase and all in lowercase. Null means this is the last one. There is nothing, no more. So in our human language, right? If I do not have anything, how do we express that? So if we don't have a book, right? If I ask you, show me your book, then in general, in your language, you say, no, I don't have a book. But is there any way I said, no, I want to see your book, show me your book? How can I? Is there any way that you can show me your book, that when you do not have any real book? No, there is no way, right? Even if you open your backpack, I will see, oh, there is nothing. So nothing means, in mathematics, we mean nothing by zero, right? We mean nothing by zero. Nothing. Symbol. In programming language, we mean nothing means null or null. Null means nothing. But this is a keyword. Most programming language that use this word to mean nothing. Okay. So so a linked list is the foundation of dynamic data structure. So in order to understand all other data structure, we should understand linked list, how linked list is formed. Since you took data structure course, right? So you should be familiar with linked list. And if you took data structure course here, data structure is taught with C++. I teach 2 sections. Must be C++. Is then forced to teach data structure with C++ because the one that you learn C++. So actually, if you program with C++, then you know actually how they are linked, other than in Java or other programming languages. High-level programming like Java, C#, like Kotlin, and then Ruby, Python. These languages have like very abstract, but C++ has very lower level implementation. So you understand this. Okay. So so node is the main element of class node. So node is the main element of data structure like linked list, stack, queue, and then higher level data structure. Almost all other data structure node is a, so you define a class node. Node can be uppercase or lowercase. Okay. So a node contains two things: some data elements, some address. Address of what? Address of next node. Okay. So data element can be like integer, is string name. This can be data element, and so in addition to this data element, it must contain another thing, pointer. Actually, Java does not have pointer, so I cannot say, but in terms of C++, you can say pointer. So here that is, but in Java it's a node next. So this next of type node, it contains the address of the next node. Okay. So in generally a node class is defined, and separately another linked list class is defined separately, and in the linked node class, create node okay, or initialize node, and the other class like linked list class that declare or define the other methods for linked list operations. like append method, prepend method, search, delete methods. We will see this one, okay? So the main thing, two things. Data element can be any kind of data, and that must, this one is a must node, and it's typed node. So if you program with C++, you understand the underlying more in mid-word level, but in Java, high level. Java does not have pointer. And there are other methods like constructor, node constructor, and some other method to handle this node class. So a few things. Each node in the node class, there is another class. For instance, there is another class that called linked list. First dash class contains a node type that is called head. So every linked list has a head. Okay. So and other methods. So head is the pointer that knows where is the starting point. Okay. And it can have tail. It can have tail. And tail indicates where is the last one. Which is the last one. Tail indicates where is the last one. This is tail and this is head. Okay. So if a linked list is empty, there is nothing in the linked list, right? And how do we know that this linked list is empty? Initially, head and tails are initialized as null. So if head equal to null and tail equal to null, then this is empty, right? But in shortcut we say if head equal to tail equal to null, then we say that it is empty. Okay, so for empty, then empty linked list, empty linked list, LL. So how about if there is only one node? If there is only one node in a linked list, it can happen, right? But she has only one node. Then it has data, for instance 10, and then this is the head and this is also tail. Okay? And this one is null. Next is null. Next is null. Next equal to null. So if head and tail indicate the same position, then there is only one node, right? And then if head and tail both null, then there is no node. Otherwise, there are multiple nodes. These are the main concept, right? So a linked list can contain any number of nodes, and the main difference between this is a dynamic data structure and array is a static data structure. So the main difference between an array and a linked list is that in an array all elements they reside in a like nearby location, in a consecutive memory location. This memory location needs to be fixed. But here these locations, these do not need to be at same position. They can be anywhere position. Anywhere. For instance, like our cell phone currently is developed with like in the concept of dynamic array. If you know someone's phone number, right? If you have a phone and he has a phone, wherever he is and you are, no matter if you call, then there will be ringing over there, right? He can change a location. But instead of a traditional land phone that we have at home and then offices, they need to be fixed place, right? So in order to receive a phone, we need to go that place. That is static. Okay, and then mobile devices are dynamic. So dynamic. So these are the concept of linked list. I'm just reviewing. I know that you should know this, but I'm asking you to recall this. So these are the foundation for other data structures, like high level data structures. So we will mainly in the next 3-4 weeks, a month, we will discuss other data types like tree. Here there are different AVL tree, red black tree, binary search tree. Okay, and then so actually you see that those for advanced data structures, those are very important. I think you learn this, you cover this in data structure course, but it is our content. Okay, does anyone has any question about this? Okay, so okay, today I will take attendance orally. I have made an Excel sheet. I will take the attendance. Okay, please remind me at the end of this lecture. Okay, not leave, please. I will take the attendance. Okay, now in most modern languages like Java, C#, Kotlin, and then Ruby, Python, these languages have linked list, dynamic linked list built in. In Java it is called array list, and C# it is called array list. It's built in already. Okay, and C++ has vector. It's called vector. That is dynamic array. Okay, and other languages have some. Python it's called list. Okay. So in this chapter actually we will start from linked list and then stack QE, right? There are two other common data structures, stack QE. So linked list, stack QE, and for all of these, and the search trees, for all of these, node is the main ingredient. So you need to have clear understanding about node, how to create a node and how to manage nodes. That is the main thing. Okay, and today we will see, and hopefully we will cover within the next 30 minutes. We will cover almost elementary. So review this linked list, stack, and QE. Okay, so just to save my time, I have my existing programs that I want to open and then share with you. Give attention, you don't need to write program right now. Okay, so I will share my program with you and then give attention. Okay. So singly linked list implementation example 1 C#, first one. This is written in C# language. This is the node class. So I was talking in node class. It can hold any number of data and it holds the next. Its type is node and its node constructor. It initializes node, and these are the other methods, for instance toString method or display node method, whatever method you want. This is an additional thing, but these are main things. These are main things. Sorry. These are the main things for a node class. Okay, once you understand node, then so the linked list class is defined separately. So here this is the head. Okay, every linked list has a head. Okay, linked list like is I usually give an example in our daily life for a linked list, like a gated community. In a community, an ideal community, right? There is a community leader, community head. Okay, and everyone knows who is the leader, who is the community head. And if you want to search for, and everyone knows, every household knows that who is the next neighbor. In an ideal society it should be, right? But we sometimes we do not know who is our next neighbor. Okay. So this is the head. So every linked list has a head. As I said, if there is empty, linked list is equal to empty, that head equal to null. I can implement tail also, but for single linked list tail is not important. For doubly linked list tail is needed. Okay. So here the two methods mainly, prepend and append method. Prepend method is used to add a node before a node, before an existing node, and append method is used to add a node after a node. Okay, but initially think that a linked list can be an empty linked list. There is nothing. You just created a linked list. So I have this linked list class, right? I can say linked list LL equal to new linked list, and a new linked list will be created. So in the main method I have this. I will share you this program with you. Okay, so this is linked list. Okay, the linked list name equal to new linked list. So this linked list initially is created an empty linked list. So empty means there is no node here, right? There is no node here. So then if there is no node, existing node, then if I want to add an element, adding means we have to consider whether I'm adding before first or after. So if there is nothing, no existing element, so there is no difference between prepend and append method. That means whatever you will add, that will be your head. The first element, that will be first element, that will be only element, that is a head, right? So you see that for the prepend and append method, there is no difference between for an empty linked list, there is no difference between prepend and append method, right? Clear? So how do we do that? If head equal to null, that means we checking that it is an empty, right? Then whatever the value you will put, the node value, you will create the node, that will be head by default. Simple. And this is same thing for prepend and same thing for append. Okay. How about if there is an existing node? For instance, okay. For instance, let me make it simple. There is an existing node. Let's consider simplicity. There is one node. Okay, so there is one node. It contains value 10. Okay, and it has next. Instead of this is for instance null, right? So this one node, there is nothing, it's null, this one. Okay, then what happens if I want to append or prepend? Append means I have to add, so I want to add this node and on one node here, and each node it has linked list, it has a head, right? So existing one, so that means it has head, this one. Existing one, that means it knows its head, right? And this one has data and next. Okay, so if I want to add this one, you can, since there is an existing, I can add prepend, I can do prepend, that means go fast, or it can go last, next. So the next is called append. So there is a difference between append and prepend method. I am trying to explain that one. So one more thing is that before, the quick thing you need to remember, for the append method you need to create the node first, this one. And for the for the prepend, did I do something wrong? For the prepend method you have to create the node, new node first. But for instance, and then for append you need to do that next, here we are doing here in this line, and in this line. So other name, node name, whatever name I give, that is not an issue. So I can say new node, I can say current node, whatever is said is not an issue. You can say new node or you can say current node. Okay, let us understand prepend method. Prepend method means I want to add this one at the top. Then if I want to add this one in the top, then what will happen? This one will be head, right? Head needs to come here. Okay, how can a head comes here? Okay, so can you say head equal to new head? Can I say, for instance, head, this is the new head, right? It has new head, it has new head. So can I say head equal to new head? No. First of all, I need to link. You need to make a brace first. Without linking, I cannot say that. I cannot say this statement first. Okay, I have to link first. So this is why, how do I link? That is here. So new head dot next equal to, so new head, I'm sorry, mistake. I did a mistake, I said something wrong. Let me tell that was for append. So here, that I can do that for a prepend, I can do that quickly. So for prepend I need to change the head, this one I need to make the head. Okay, so new head dot next equal to head, so head will become over here, and then head equal to new head, so that this one will be new head. So new head, actually what is there, so you see there is a set method over here. So this is in the program you will see set method. So if you use setter method, then you will use this way. Okay, but if you do not use set method, then you will do traditional like this way. So new head dot next equal to head, and head equal to next node, and this is the way that head, this one will be head. Okay, and then in that case, so sorry that I did a mistake, the linking will be like this way, other direction. First of all, I need to say new head dot next equal to head. So new one, so this linking is that like this way. Sorry. the linking is the way that, so this is new head, this is new head, this has very slow, new head dot next will be this one head, what is head pointer, okay, and then head equal to new head, then head is coming here, so then it got the top element, okay. But for the append method, you need to say, you need to save the head in a current node position, and then these are the statements. So this statement is finding the all the way, it is going all the way to the linked list. We don't know how many elements are there in the linked list. If there are multiple elements, more than elements, so this one will say well current dot next equal to null. That means this one until we find this position where this node dot next equal to null, this one had next equal to null, then you have to go over there, okay. So then until you find that not equal to null, you will be moving from one step, that you will be going all the way in. Like a linked list is a like restricted stairway. You cannot, the restricted stairway, that you can only step on one step, you cannot jump a step, skip a step. Like there is a stairway over there, if you walk through, sometimes you can skip a step, right? But in a linked list there is no way, you have to go one by one. Okay, so here when we go all the way in, then you say current node equal to current node dot next, that means this node will be current node dot next, it will be, and then current node dot next, it will come here, this existing node, last node, current node means last node, it will be your new head, okay. So if you understand this append and prepend method, then there are other methods in linked list that are easy to understand. Okay, I'm sharing my programs to you. So everybody has a Replit account here, right? Okay, so I'm sharing my code over here, so please at least save it in your account. How do you save it? Just fork, right? Fork means even I've changed my program, I've deleted my program, you will still have a copy. Here. For this one, I have C# program, and all of my programs, if I have C# program, then I have same name with Java. I have the program in Java. So this one Java, and then I have stack. Let me give it a program, and then I will come up stack, and then I have Java, I have C#. Okay. So you see that linked list, this one, this node is same for linked list, stack, and queue. Okay. So in a stack, there are few methods only. Pick to get the top element. Okay. In a stack is called a leaf or FIFO. You can remember. Stack is called a stack is last in first out or first in last out. Huh? Yes. The stack is called last in first out. That means like this. Is one side is closed, this side is closed. So in a stack of plate, so whenever we wash or dish other plates, we put one above another, right? The stack of plates, so that usually that we wash the last one, we use that on the top. Okay, one side is closed. So this is had, so it has top. It has top node. Okay, so this is called peak operation. Peak operation is getting the top element, just getting the top element. It does not delete the top element. And then pop operation means deleting the first operation, first node. Okay, and push, that means adding an element in adding a node in a stack. These are the three main operations. Okay. So compared to linked list, stack operations are fewer operations and easier. Okay, so I'm giving you, so just play with these programs, so if you need to recall this. Okay, and then okay, one more thing that I forgot to mention. In linked list, stack and QE, there is also operation is called delete operation. So in a linked list or stack or QE, for instance, we want to delete this node. This means we want to remove this. Delete means we want to remove this node from my linked list. It does not mean that it will be deleted from memory right away. It will be staying in memory, but we are just delinking. For instance, there is a link over here. We are unlinking this one from linked list. We get connection from here to there. For instance, if you have a friend in your friend is Facebook friend list, right? If you want to unfriend someone, remove someone, right? Just you do unfriend. That does not mean that that person account is getting to be deleted. Just it is unattached from your friend list, right? But from your group. So this is actually, so for all stack data structures, we don't delete actually. So in delete operation is difficult. For instance, even in single linked list, in array, if you want to delete an element, what do? Deleting and inserting in the point, we need shifting, right? So if you want to delete these ones, for instance, then you need to shift this element over here. That means overwrite, right? Overwrite, and you need to shift all of the elements. All of the elements. It is not that you can put 0 over here. Okay, all data structure will not allow. Maybe your data is different. 0 or null. Okay, so but for array, this means for array, this deleting means overwriting, and for dynamic data structure, deleting or removing means just unlinking. Remove the link. Okay, so one more thing that we have, QE implementation program in C++. Okay, I got C# first. C#, this one, and I have also Java. So QE is a FIFO, first in first out type data structure, like we line the line for ticket. or cache register is a QE. So same node structure, and but a QE, it has head and tail. If head or tail, head equal to tail null and tail equal to null, then it is empty. And there are some few operations, like you can do pick operation, who is the top of the QE, or bottom, who is the end, or you can do NQ, that means adding an element in a QE, and DQ operation, removing an element from the QE. Okay, and then you see competitively in competitive from linked list, stack, and queue implementation. Very easy. Okay, then these are the data structure, you already know about this. And another, there are other data structures like tree structure, right? As this covered in your 13 is data structure course, tree. Okay, that's good. So for instance, tree structure, another data structure is tree. So tree, so in naturally we see tree, it has a root and branches, and all the top level are leaves, right? So in programming, so in a programming language, computer programming perspective, we denoted tree, but reverse tree. This is root, okay, and these are branches, these are branches, these are branches, each branches has sub branches, okay, and then these are, maybe there is no branch, then these are leaf, if there is no branch, this is leaf. So in a real life, for instance, we have tree structure or our family structure. So this is maybe grandfather or great grandfather, this is maybe means my father, okay, and my uncle 1, uncle 2, aunt 1, aunt 2, okay, and maybe I have, this is me, okay, and then I have my brother, sibling 1, S1, I have brother, sisters, and maybe I have my own son, and I have nieces, right? These are the family structure, family tree, we call this family tree. This go like this way. So, but this kind of tree implementation is difficult. So if there are any number of branches, okay, but for the simplicity, so there is new kind of trees that we will learn here. So next few weeks we will discuss. The one is called ABL tree, then another called red black tree, okay, and then the simple one that you should be familiar with, a binary tree. Binary tree. I put a gap. I have to write something over here. So binary tree, that's bi means 2, right? So that each node has exactly 2 children. If there is a child, there are children, then exactly 2 children, not more than 2. Not more than 2. Not more than 2. This is binary tree. Okay. Every person has 2 children, not more than 2. Okay. This is easier to implement. So if you have this side is the left branch and that side is the right branch. Okay. For simplicity, let us make this one. Okay, exactly 2 nodes, and each node contains data variable, right? Data and also the address of the next node. Okay, every father knows who is his children, who are his children. Okay, and then there is a common popular one is called binary search tree. Okay, binary search tree is just a different kind of special kind of tree. Okay, the binary search tree is special. It depends. It has the special kind of data. It holds special kind of data. Its data is that the node element, the node root. This is called root or father. Always has value greater than its children value. One property, like family structure. My grandfather has age, right? More than or more age value than my father and my uncle. Okay, so maybe this is maybe 30 and maybe I'm sorry. No, I'm sorry, it is a mistake. So every node, okay, every node in the binary search tree, every node has value. Okay, that is left is value is greater than the left child. It's not binary search tree is not a family structure. And the right value, right child has value greater than this root node. Is not a family structure. Okay, so this one is 50, then if it is 30, then other values must be this side, all this left side is less than 30, and right side can be greater than 30 but must be less than 50. Okay, and this other side all values must be greater than 50. So this one, okay, must be at least it can be at 51. So 50, right? If we say numeric value, integer value, then can be this value less than 60 but must be greater than 50. Okay, so all this way, so all the right we can say this is left subtree. My pen is why is that behaving something different, slow. I don't know why it's slow. This is left and this is right. So binary search tree is built upon the data values. There are two conditions. Must be there are two binary, two children, and each child, okay, will hold value greater than its left child. If not, will hold value greater than its left child but less than its right child. So in this way, so a binary search tree is developed. So for instance, if this value is 10, this value may be 20, and this value may be 51, and this value may be maybe 61. Okay, so there are some common operations for binary search tree. Binary search tree is mainly developed for searching operation. Okay, every time you see that, if you check for a value, for instance, if you want to check whether 27 exists in this tree or not, then you will check start from the root. 27 is less than the root value, so it will go to the left side. You don't need to go right side. So that means array size is getting half. Sorry, tree size is getting half, right? Every time tree size is getting half. Okay, so that means You are checking, so when you are getting half, that means you are getting some constant of, for instance, log n with base 2, something logarithmic, time complexity. Okay, so let me get my program to you, then we will discuss. We have a few more minutes, then we will discuss the implementation and use of binary search tree. Okay, so binary search tree example 1. By the way, most of the modern programming languages have this dynamic basic data structure built in, like C++ has array list. So Java has array list, and that is dynamic linked list, and then C++ is called vector. Okay, the binary search tree. You see that binary search tree, it is used as a recursive method. So you see that binary search tree is this one that I'm looking for. No, not this one. I'm looking for something else. I'm looking for implementation. Bst. Okay, this one, binary Bst implementation C#. Okay, this one, Bst implementation is the same node, no structure, and Bst class, and this is insert method. This has delete method, and main 3 operations. There are traversing operations. Okay, I'm looking for this one. Give it this one. So you got 1, 2, 3, 8 programs, right? 1, 2, 3, 4, 5, 6, 7, 8 programs. Okay, save this in your account, please. Okay, let us, we have a few more minutes, let us discuss this. So this same node is a little bit different, that it has left and right, left child and right child. So these are 2 nodes, left child and right child. So that means a node, when a node is created, that is left child is empty, right child is empty. Okay, and a BST is created as a root equal to null. That means there is no root, that means there is no tree. So how do we check that is an empty? If root equal to null, it is empty. Okay, so you can see this operation, but I'm running this program. For instance, I have a tree like this. I want to create a tree. I want to make a tree like this, 40, 20, 60. You can see? Okay, 40, 20, 60, 10, 30, 50, 70. So this is a binary search tree, right? Each node has 2 children, and each value and the node value contains value greater than left child and less than right child for all cases. So this is the BST. Okay, so the BST, the 3 operation is called traversal in order operation, and then pre-order operation, and then post-order operation. So based on this word, in order, pre-order, post-order, the traversal results are different, right? So let us understand what is in order of what. The question, in order of what? In order of actually a node, right? Parent. We want to emphasize whether our parent will go before us or our parent will stay between me and my brother, or our parent will follow us, right? So let us go this 3 first. So let us go this. I need to make the same thing. Let me make the same thing. So 40, 20, 60, 10, 30, 50, and 70. Same, I put it here. Okay, so let us make it 2 subtree. These are the 2 subtrees, right? This is 1 subtree, and this is another subtree. Okay. We are concerned about the in order, pre-order, and post-order. So in order, so we'll come back to in order later. Okay. So let us understand the pre-order first. Pre-order is giving emphasis to father. Father will go first. Okay, the parent will go first, or root will go first. Whatever you say, parent, father, or root, same thing. Okay. Okay. So for the pre-order, this father will come first. So 40 will come first. So for pre-order, 40, then we will go left subtree, then 20, then we will go left, then 10, right? Then we got 40, 20, 10, and then what is next? So you are done here, right? You don't have any more step. This is bottom or leaf. Then we have to go this one, because you already covered 20, so then you have left your brother, this one. So here 30, and then now you have to go to right subtree, and again we have to give same order. So you are doing pre-order. So it's 60, and then left 50, and then 70. Do you understand this? It's easy, like, okay. And then post order, that means what we will cover, the parent will follow us. The parent will go after us. Okay, so post order. So our parent, so skip parent, and then come to here. There is no more parent, so 10. Then skip parent, go to 30, and then now for this one, go to parent. Parent will follow the children. So 10, 30, and 20 for this subtree. Okay, then we will this parent will come later. Okay, we will skip this, then we will go this side. This side also parent will go later. So then 50, then 70, and then 60, and then all the way later parent 40. this is the post order. This is the parent one, 20, this is the 60 parent one, and 40 is the top parent. Okay, and another thing is that is called in order. So for in order, our parent will be surrounded by his both children. Okay, then the left children will come first, then parent, then right children. Okay, so that means 10, 20, and then 30. And this subtree is done, right? Then parent. Before you go to right child, right subtree, this parent, right? Parent is 40. So this is the root 40. And then you are going to right subtree, and then parent will be in between two, then 50, 60, 70. 50, 60, and 70. Okay, this is the right subtree, and this is the parent, and this is the left subtree. This is in order. So in order traversal, it also shows us something. What is that? It also gives us something. Do you notice something from the in order result? What is that? No, values are sorted in ascending order. Right? For the in order sorting, in the binary search, these values are coming in ascending order. Okay, so this is a quiz question or interview question sometime. If for in order traversal, you will get an ascending order. Okay. So I gave you this program, right? So that's all for. I will take that in this place. So that's all for tonight. And then please, before we come to our next lecture, please at least save my programs. Okay, open this program and save this. And another thing is that be ready for the next time test. Next week, your class time will be test. Okay, as you know, in the syllabus there is no makeup, but there will be makeup, but you will lose that substantial amount. So if you miss a midterm, at least you will go one little grade down. I don't like you to do that. Okay. Okay, and then give me a few minutes, so then I will take the attendance. But before I wrap up, does anyone has any question?
I got one.
From this?
About the study guide.
Okay, for the study guide, okay, yeah.
The tracing code, what is that?
Tracing code means I'm giving you some code, you will analyze the code.
Analyze it?
What is happening, what is missing, what is wrong, something like this.
Okay.
Okay.